Recording is rolling. It is Monday, April 27th. So we're going to do the very last lesson out of the book, 11.5, inverse matrices.
Wait, are we done with notes after this?
Well, yeah, because this is kind of the last main stuff that I got to teach you guys. Okay. All right, so I'm going to give you guys notes on these 5 examples, and then leave these 5 to you guys independently. Alright, so on this page, some of these I starred, those are the ones I'm doing with you guys, but some of these I circled, and that's the ones I'm leaving for you guys to work on independently. Okay, just the ones that are circled, just like last week. Okay. Tomorrow I'll do a Kahoot review with you guys for module 11. Wednesday will be an Alex and work day, and then I'll get you guys your module 11 quiz on Thursday. Right, so what is an inverse matrix? And then what can you do with this? Right, so let's say you got a 2x2, and really your book just focuses on 2x2s for this particular lesson. You can do this with 3x3, but your book didn't go to that level of detail, so we'll just stick to 2x2s. So let's say we got these elements A, B, C, D. Now, if you reverse the positions of the A and D, see how I swap the places of those on the top left and bottom right corner? D and A, swap places. Okay. And then elements B and C stay in place, but they become negatives, the negative version of themselves. Okay. And then furthermore, if you multiply that by the scalar factor of 1 over the, ooh, guys, what is this right here? It starts with the D. It's called the determinant. Yeah, do you have to remember determinant? Okay. So if you do 1 over the determinant of this arrangement of the elements, then that will give you the inverse matrix. Okay, so what's that good for? Well, one thing is if you multiply the original matrix times its inverse or vice versa, you get. Did you guys come across what this is called? Starts with an I. It's called the identity matrix. Identity matrix. You get 1, 0, 0, 1, or if it was a 3 by 3, it'd be, well, the ones would just fall down in the quarter side, right? That's what's wrong. Okay. Also, you can use inverse matrices to solve systems of equations, and so I'll eventually do that with you guys too. And so let's at the beginning here. This first section says determine whether each pair of matrices are inverses. Okay, so I'm leaving number 4 to you guys. Gonna do number 1 with you guys. Okay. Okay, so number 1. Oh, and then write your name on your paper. Yes. And this says 11.5 notes.
I assume we'll go over what new.
What was that?
I assume we'll go over what inverses then we could.
Inverse? Yeah, we're gonna do a bunch of examples. Okay, so number 1. Okay, so they give you P, which is, here, I'll just go right now. 1, 0, negative 2, 4. And Q, which is 1, 0, 1/2, 1/4. Okay. Yeah. Okay. Now, one way to determine if 2 matrices are inverses of each other is I can simply multiply them together. And if I get the identity matrix 1, 0, 0, 1, then that means they would have been inverses. Okay. So I have a 2 by 2 matrix here and a 2 by 2 matrix here. These 2's, remember, the fact that these inside 2's match means that you can multiply it. And the product matrix is going to be the outside dimensions, which is also 2 by 2. Okay. Okay, so that's it. Now remember how to multiply matrices. So we start with this 1 times 1, and then I slide to the right on the first matrix and go down to the second matrix. You guys remember that from last week? So it's 1 times 1 plus 0 times 1/2. So I'll just say plus 0 for now, space there. Okay. Next element. So the top right element up here. So you got 1 times 0, which of course is 0, plus, and then it goes away. Okay, well, this is also 0 times something. So it's just 0 plus 0. You see that 0 plus that 0. Okay. How about this element 2, 1? So that's negative 2 times 1 plus 4 times 1/2. And then finally, this last element is negative 2 times 0 plus 4 times 1/4. So 0 plus 4 times 1/4. Okay. And so that's our matrix multiplication. Okay. And let's see what this simplifies to. Well, 1 times 1 is 1, plus 0 is 1. 0 and 0 is 0. This is -2, this is +2, so doesn't that also all zero out? Okay, and then, ooh, guys, what's a quarter of 4? 1. Okay. So the fact that this is the identity matrix means that those original matrices, so P and Q, that's matrix P and matrix Q, are inverses of each other. Right? Okay, guys, go to number 1.
What you multiply is by doing like, for example, if you're doing the one on top left,
Huh?
it'd be one and then the zero, or 1 times 0, and 1 times 1/4, right?
Okay, so go through this multiplication. Okay, so 1 times 1 plus 0 times a half. That's this. Okay. Then 1 times 0 plus 0 times a quarter, so 0 plus 0. Then I got -2 times 1 plus 4 times a half. That's right there. And then finally, -2 times 0 plus 4 times a quarter. Okay. Now, another way you could determine are these inverses is you could have started with one of these and then found the determinant and gone through this process, which is exactly what we're going to do for the next couple examples. Okay, you guys ready for the next couple examples?
Yeah.
Ready? All right, let's go. Here, I'm doing number 5 and 8 with you guys, and if you guys number 6 and number 9. So number 5, we got to find the inverse of 10, -9, -4, 6. Here, I'll call this matrix A. How about that? Okay. Well, one thing I gotta find is what's the determinant of A. Okay. You guys remember how to find the determinant of a 2 by 2?
Oh.
Guys remember this? I'm gonna go 10 times 6, and then subtract, and then -4 times -9. Is that right? That's the, here, I'll spell it out. Determinant. So that looks like 60, and then ooh, 3 negatives. That's overall negative. 36 is 24. Oops, 24. Okay. So that's the determinant of that 2 by 2 matrix is 24. Okay. Now, A inverse then. So this would be your inverse matrix. You can use this notation, A -1 equals, okay. So I need 1 over 24, because 1 over the determinant, multiplied by, and then, here, I got it right here, I got it right here. Okay. So remember I swapped the positions of A and D, so A and D became D and A. Okay, so what should I write right here? 6. Well, it goes right here. Yeah, yeah. You guys go 6 and 10. These swap places. Okay. And then it looks like these other elements I just left in place but made them negative. So that number goes right here. Yeah, 9 and 4. Okay. I got 1/24 times that whole thing. So see, since this is a scalar multiply, I can go ahead and just multiply it into each element. So 6 over 24 reduces to what?
1.
Yeah, 1/4. Then 9 over 24, I think you divide by 3. It's like 3/8, I think. 4 over 24, it reduces to 1 over 6. And 10 over 24, it's like 5 over 12, isn't it? Okay. So there you go. That should be the inverse. Okay. Now, if you wanted to check, if you took that inverse and I multiply it by the original matrix or vice versa, you can multiply them in any order. Okay. Here, it's a little hot cloud here. Okay. Guys, this would be equal to what?
1001.
Exactly. Okay. And that's what we did with the last one. Oh, yeah, go ahead.
Does the inverse have its own determinant?
Yeah, the inverse can have its own determinant
So
too.
I'm thinking, shouldn't we just do the same thing we did on the top, but then divide by, or multiply by 1 over 24? Like that work?
So you're saying do what?
Never mind.
No, all right. Okay. All right. So you guys get there. Let's get there. All right, let's do basically another one of those. All right, so I got number 8 queued up here. Number 8. All right, so I'll call this matrix B. How about that? We got 8, -2, -4, 1. Let's find determinant of B. B 8 times 1 minus -2, -4. 8. Uh, guys, what would this be equal to?
0.
0. Right. Well, if I continue this process and I try to get the determinant of I try to get the inverse by doing 1 over the determinant. Okay. Guys, am I allowed to do 1 divided by 0?
Yeah.
No. So what do you think the answer is?
Not possible.
Yeah, undefined. Okay. So this is yeah, so 1 over 0. Right. Let's say no solution. Okay. All right. All right. And then just double checking the ones I gave you guys because I can see the teacher's edition over here on the side. Yeah, okay, so looks like I gave you guys ones that actually do work out. Hey, you guys ready for the next one? Okay, 14 and 15 are both word puzzles. I'll do 14 with you guys. Rafaela buys coffee and bagels for her.
You have a staple.
Yeah, there's staplers over there. For her workmates every Monday. Last week she bought 4 cups of coffee and 3 bagels and paid $12.90. Now, pause right here because you can kind of get where this is going. Guys, at this point, if all you have is that first sentence, do you know how much coffee costs or how much bagel costs? Not really. It's very kind of ambiguous. Okay. This week, she bought a different number of cups of coffee and a different number of bagels and paid a different total amount. Okay. And I think at this point, we could solve it. And that's the question. How much does a cup of coffee cost and how much does the bagel cost? Okay. All right, so 14. Okay. I think what I'm going to do is say 4 cups of coffee times the price of coffee plus 3 bagels times the price of a bagel has to add up to $12.90. Okay. And then later on, 5 coffee, 5 bagel, 5 cups of coffee plus 5 bagels, that adds up to $18. Okay, let me check. Okay. So C represents price of coffee, and B represents price of a bagel. Right? So 4 cups of coffee, 3 bagels, 5 cups of coffee, 5 bagels, and she's paying the sum total. Right, that makes sense, right? Right. All right. Now, guys, could you, if you want to, could you use either substitution or elimination and get the answer out? Yeah, you could. But this is just a different way to look at it. Is we could set up a matrix. So let's take these coefficients, these which represent the number of each that you bought. So 4, 3, 5, 5, make a 2 by 2 matrix out of that. 4, 3, 5, 5. Okay. Then I'm going to say multiply by, and I'm going to have a 2 by 1 matrix, which is coffee, bagel. Right. That remember these represent the price of a cup of coffee and the price of a bagel. And then out of that, yes. Which one? Okay, yeah, can we do this thing? Yeah. All right. And out of this, we're gonna get these total amounts that she paid, $12.90 and $18. Okay. Now, before I go on, I want you guys to see that this would work with matrix multiplication. Okay. Here I have a 2 by 2 matrix here and a 2 by 1 matrix here. Okay. So this 2 matches this 2. Yes, I'm allowed to multiply those matrices like that. Remember, matrices, it doesn't matter the order you matter. Multiplication is not commutative with matrices. And the outside numbers at this 2 and this 1 tell you that the product matrix is also going to be a 2 by 1. Okay, which is okay. I got 4C plus 3B equals 1290. hey, that's what this equation said. 4c plus 3d is 1290. Well, how about the rest of this? 5c plus 5b equals 18. Oh, that's what this equation said. Okay, so you guys see how this system of equations, this system, can be exactly represented by this matrix? Right. Yeah, that matrix setup. Okay. Okay, so now what? Well, hey, what if I took this coefficient matrix in front, this 4355, and I was able to divide that over? Wouldn't that leave me with just C and D and then I would have the answers? You think that way? Okay. So how do you divide a matrix? Oh, that's what the inverse is for. See, if I have the inverse and I multiply both sides by the inverse matrix, then on the left side I would get the identity matrix and I'd basically just be left with C and D, and then I would have the answer. So let's find the inverse matrix. So inverse matrix. So I need 1 over the determinant. And then times, and then I need to swap some things. So it's 5 and 4 swap places, and this bringing this 5 become negative with that. Okay. But what was the determinant? To be 4 times 5 minus 5 times 3. Is that 20 minus 15? Which is 5. Okay, so the determinant is equal to 5. Right, is that right? Determinant's 5. Okay. So now we know that. I can say the inverse matrix is 1 over 5, right, times 5, -3, -5, 4. Okay, like that. Okay, and then, yeah, let's go clean that up. So that would be, well, that's 1, and that's -1. And then over here, I got -3 this, and I got 4 this. Okay. Okay, so that's the inverse. All right, guys, do what that's the inverse. All right, next part.
No, the inverse of
Yeah, what's that?
the inverse opponent.
How to form the inverse is. Alright, if you have elements A, B, C, D, A and the D swap places, the B and the C become negative, and you multiply by 1 over the determinant.
Okay.
Yeah. Alright, so I'm gonna say that inverse matrix 1, -3 this, -1, 4 this, multiplied by the original matrix 4, 3, 5, 5. And then price of coffee, price of bagel equals. Okay. Then on the right side, remember I just used to have these the total bills. Okay. Well, I'm multiplying in the inverse matrix, so I'll multiply that in right here. So 1, -3 this, -1, 4 this, and then the price values of $12.90, $18. Okay. Okay. All right. So if you know what we're doing and why, then it's not too bad, and you can get the hang of this. Okay. Okay, so here, let's do a recap. So I started off with the system of equations that looks maybe really familiar from Algebra 1. Okay. And I turned that into this matrix looking form. And I was doing the matrix multiplication. I was like, yeah, that actually does lead back to that system of equations. So these are your two representations of the same thing. Okay. Now, this very last line, notice if you block out the inverse matrix part, it's exactly what I'm holding in my left hand right here. You guys get the same thing? Okay. So all I'm doing is I'm multiplying in the inverse matrix, which is 1 over determinant and the whole process. Okay. Reason being that I think this part right here is going to come out to the identity matrix. Okay. Now, once you do enough of these, you can just kind of skip past that because everything on the right is going to be the answer. Okay. And so this should be identity matrix. And this over here should represent the answer eventually. We just have to solve it. Okay. Right, is that okay, that process? You think so? Okay. Right, now it's really good for completion here. I do want to show you guys, this is gonna consolidate to the identity matrix. Okay, so I got C, B, so I got that. Well, something. Okay, so it'll be 1 times 4. Okay, I'll just do this on my calculator screen. So 1 times 4 plus -3 fifths times 5 plus -3 fifths times 5. 3, oops, plus. There you go. It's 1. It's 1. Okay, so this is 1. Okay. How about 1 times 3? 1 times 3 plus -3 fifths times 5. That is 0. Is 0. Okay. Then bottom left, I got -1 times 4. -1 times 4 plus 4 fifths times 5. Yeah, also 0. Here. Yeah. And finally, -1 times 3 plus 4 fifths times 5. And that is 1. Yep, that's exactly what I was looking for. And if you do a bunch of these, you can kind of skip that step, but yeah, it's nice to stay confirmed at least once. And then over here, we're about to get the answer. We just have to multiply this. So let's do 1 times 1290. So 1 times 12.90 plus, and then -3 fifths times 18. 3 fifths times 18. Okay. And I'm getting 2.1, or say 2.10. Right, and then down here I got -1 times 1290. -1 times 1290 plus 4 fifths times 18. Right, and that's giving me 1.5. I'll call it 1.5. And now I have the answer. Right, you guys see what it is?
Yeah.
Okay. So price of cup of coffee and price of a bagel. Okay. So you guys are following. Guys, what's the price of a cup of coffee? Yeah, $2.10. And a bagel?
$1.
At $1.50. Okay. If that's really true, then I should be able to go back to that original system, pick either equation and plug it in, and it should confirm that. Let's see. How about this top equation? Let's do 4 times a cup of coffee, we said is 210. Plus 3 times bagel, or bagel is 150. Okay. And this should tell me $12.90, shouldn't it? $12.90. And it is. It is exactly. Okay. Let's do 5, 210 plus 5, 150. That's 18. So they both worked out. Yeah, they both worked. All right, you guys get coffee bagels. Bagels. All right. All right, let's do one more here. All right, so they have just plain system of equations. So these are a little more abstract, but you know what? I think this section is really kind of what we just did, just without a story attached to it. It's the same idea. So number 19, I got the system of equations 8x plus 11y is 24, and -x plus 4y is -3. Right. Again, you have old methods of doing this substitution, elimination, blah, blah, okay. Let's make this into matrix style. Good, what 4 numbers go here, 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 and here.
8, 11, and -1 and 4.
Exactly. And how about here, here?
X and Y and a Y.
Yeah, that's what. How about here, here? 24 and -3. Right. So we got 8x plus 11y is 24. Yep. And -x plus 4y is -3. Yep. Big, all there. Right. Now let's find the determinant of the matrix. Would that be 8 times 4 minus -1 times 11. It's like 32 plus 11. Is that 43, I think? 43? I think that's right? And then the inverse matrix, therefore, would be 1 over the determinant, which is 43, times. And then I'm going to swap these two places, so the 4 and the 8 swap places. And these two numbers become the negative values. So go like that. All right, all right. All right. You know what, here, I'm gonna do one more thing. We go ahead and put that 1 over 43 in there. This is 4 over 43, -11 over 43, 1 over 43, and 8 over 43. I think 43 is prime, so yeah, I can't really reduce that. All right. Huh?
Is that -3? -X plus 4 then it's -3.
This is a -3. Oh yeah, sorry, it's those two here. All right. Okay, you guys got that? All right, now let's take that reciprocal matrix, multiply by, well, both sides, I suppose, right? For balancing the equation. So it's gonna go 4 over 43, -11 over 43, 1 over 43, 8 over 43. Times 8, 11, -1, 4. And xy equals 4 over 43, -11 over 43, 1 over 43, 8 over 43. Times 24, -3. Yeah. Alright, so just like before with the coffee and the bagels, if you cover up this inverse matrix on both sides, yeah, that's the original matrix that we had to represent the system of equations. Okay. And then if I simply multiply it back in there, and I'm only allowed to multiply it like that because of how you're allowed to multiply matrices. Okay, got both sides balanced. Okay, is that right? Okay. Now, if I do everything right, this bit here should be the identity matrix. Here, I'll test at least one of these elements. Okay. Let's do 4 out of 43 times 8, and then plus -11 out of 43 times -1. So the negatives are going to cancel. So I'll just say 11 out of 43 times 1. 4 out of 43 times 8. Oops. Plus. There you go. Right. And I get a 1, as I should get. Okay. Now, if I tested all the other elements, I should get 0, 0, 1 to make the identity matrix. Okay. Okay. And then I have xy. Yeah, because got x plus 0, y is x, and 0x plus y is y. Okay, that makes sense. Okay. Over here, I have a 2 by 1, or sorry, a 2 by 2 matrix and a 2 by 1 matrix. So the product should also be a 2 by 1 matrix. So 2 by 1. Let's do 4 out of 43 times 24 plus 11 out of 43 times 3. And these are both negatives, so the negatives are going to cancel. So that times that plus that times that. Okay. Oh, I got a whole number. I was not expecting that. All right. Got this. Okay. And then this next element, got 1 out of 43 times 24 plus, okay, no, this one is negative, so 8 out of 43 times -3. So that times that plus that times that. And, ooh, I got 0. Okay. So it looks like x is equal to 3 and y is equal to 0. So that should be the answer. One last thing I do want to check is if I take those answers and I plug it back into the original setup, the original system of equation, do I still get the correct answer? Yeah, that'll fit right there. Boom. Let's check this. So 8 times 3 plus 0 is 24. Yep. And -3 plus 0 is -3. Yeah, that totally works. Okay, first second. Okay, so double check, make sure your name is on your notes. Turn those into grade tray, and yeah, you guys have rest of class to be trying those independent questions.